This is problem 33 from chapter 16 of the textbook Stats Modeling the World, second edition. Okay, so what we're working with here is we have a small bowl with cereal in it, I guess, and a large bowl. And we're told some information. So the expected value of the small bowl, so I'm going to use S as my random variable, is 1.5 ounces, and the standard deviation of the small bowl, the amount that's in the small bowl, is 0.3 ounces. And then for the large bowl, so I'll use L as my random variable for the large bowl, there's an expected amount of 2.5 ounces with a standard deviation of 0.4 ounces. So this is the given information. So the first question is, how much more cereal do you expect to be in the large bowl? Well, I could find that out by having a difference. I could say let D be the random variable L minus S. But I'm just going to go ahead and use L minus S to remind me of what I'm talking about. So L minus S, that's just going to be the expected value of the large bowl minus the expected value of the small bowl. So that's 2.5 minus 1.5, so 1 ounce. Okay, so that's pretty straightforward. That's the expected value. Now they want to know for part B, what's the standard deviation? So we have to work with variances first. So we want to know what's the variance of the large bowl less, so to speak, the small bowl. Well, we have a rule that the variance of x plus or minus y is equal to the variance of x plus the variance of y. So the variances add even if you're subtracting. So this would be the variance of L plus the variance of S. Okay, now we also want to remember that the variance of any random variable is the standard deviation of the variable squared. So what we can do is we can go up here and we can get the standard deviation of the large bowl is 0.5 square, or is 0.4, and then to make it the variance we square it. And then for the small bowl it's 0.3 right here, 0.3, and then we're going to square that. So we get that's going to be 0.16 plus 0.09, which is 0.25. That's kind of a nice number. So the standard deviation of the difference, the large bowl minus the small bowl, is just the square root of 0.25. And so that's going to be 0.5 ounces. So for the difference, we have an expectation of 1 with a standard deviation of 0.5. Now, ounces. So if the difference follows a normal model, so what they're basically saying is if L1 minus S, that difference is normally distributed, and so therefore we would say, we use this notation, then we would say it has a mean of 1 and a standard deviation of 0.5, and it's normally distributed. So they say, what's the probability that the small bowl contains more than the large one? Okay, so let's see, what are they talking about then? So they want to know what's the probability. So we could say we're interested in the probability of, that's how I read the parentheses, L minus S. So if the small bowl has actually more in it than the large bowl, then if you take the difference would always be negative. So we would say less than 0. Okay, now I know a few students are kind of looking at me funny, like I've kind of gone off the deep end. How can a large bowl have more than a small bowl? So I'm going to digress just for a minute and say, okay, here's the large bowl, and here's a small bowl. Okay, so let's put some stuff into the small bowl. So there's the stuff in there, the cereal. Hopefully it's good for you. It doesn't have a bunch of sugar in it. Okay, and then here is something in the small bowl. I mean the large bowl. Okay, so this is the large and here's the small. So clearly there is more in the small bowl than the large bowl. So theoretically possible. So what would this be? Well, if we draw a normal model, I can tell I'm going to run out of room here. So I'm going to draw the normal model right here. Best I can. No laughing. So there it is. So it has a center of 1. Okay, 1. And then if we subtract off standard deviation, that would be 0.5. And that would be 0, 2 standard deviations away. And this would be negative 0.5. And of course, we go this way, this would be 1.5 and 2 and 2.5. So this is the model. Now we're interested in less than 0. So we're interested in the area under the curve right here. Okay, we want to know what is that area, because that corresponds to this probability question. So to do that, we need to find the z-value for that location. So the z-value, if you remember, is the observed minus the expected divided by the standard deviation. So the observed here would be 0 minus the expected is 1 divided by the standard deviation. So we get a nice even negative 2. Which makes sense because we're 2 standard deviations away. So now this becomes the probability of z less than negative 2. And we can use our calculator to do that. So we could say normal CDF of, and we want to go from negative infinity to negative 2. So we're going to approximate that with, we're just going to put in, this number here and then put in negative 2. And that's going to give us about 0.023, or approximately 2.3%. Okay, so according to the normal model, the probability of this occurring, this difference being less than 0, in other words, the probability of the small bowl being greater than the large bowl, is about 2.3%. Okay, so I spent a lot of time on that. Let's take a look at these other problems real quick. What's the mean and standard deviation of the total amount of cereal in the 2 bowls? So that would be the expected value of the large bowl plus the small bowl. So we're just adding. So that's the expected value of the large plus the expected value of the small. And so if I recall, it was, what was it again? 2.5 and 1.5. So 2.5 plus 1.5. So that's going to be 4 ounces. Okay, now the standard deviation, let's start with the variance. The variance of L plus S is equal to the variance of L plus the variance of S. But hey, that looks kind of familiar. We've already done that. That's right here. That's 0.25, and the square root of that is 0.5. So we don't have to do that over. We've already done it. Okay. So the standard deviation of L plus S equals the square root of that, so 0.5. So we've done all the work from part B. Okay, now two more problems. If the total follows a normal model, so once again we have a normal model. So let's draw it the best we can. No apologies needed. So now our expected value is 4.0, and our standard deviation is still the same. Okay, so what's the probability you pour out more than? So what's the probability that L plus S is greater than 4.5? Well, 4.5 is going to be one standard deviation away. So we want to know what's the area under the curve right here. So that's just going to be equal to the probability of Z greater than 4.5 minus 4 divided by 0.5. And let's see, that's also going to be 1. Wait, yeah, it's going to be 1. So that's the probability of Z greater than 1. So normal CDF, and we're going to go from 1 now, because here this is 1, to positive infinity. Okay, and so that becomes 0.159, or approximately 15.9%. Okay, so according to the model, the probability that the total weight of cereal in the two bowls is more than 4.5 ounces is approximately 15.9%. Okay, last problem. The amount of cereal the manufacturer puts in a box has a random variable of 16.3, so expected value of a box is 16.3, and it has a standard deviation of the box of 0.2. Find the expected value of the cereal left in the box and the standard deviation. The amount of cereal the manufacturers put in the box is a random variable with a mean of this standard deviation. Find the expected amount of cereal left in the box and the standard deviation. So I suspect what's going on here is that we have a cereal box. There it is, brand new from the store, and it has 16.3 ounces, and then we're going to pour some out into the big bowl, so it's going to go down, and then we're going to pour some more out into the little bowl, and it's going to go down some more, so it's going to go down, and it's going to go down. So I believe what they're asking us to find is what's the expected value of the box minus the large bowl minus the small bowl. So that's just going to be the expected value of the box minus the expected value of what's in the large bowl minus the expected value of what's in the small bowl. So if this is 16.3, then this is going to be 2.5 minus 1.5, so we're going to get 12.3 ounces. Now, but that's not the fun part. The fun part is the standard deviation. So let's start with the variance. The variance of the box minus L minus S is going to be the variance of the box plus, remember variances add, plus the variance of the large plus the variance of the small. So that's going to be 0.2 squared plus 0.3 squared plus, oh, I think I switched it. This is 4 squared and this is 0.3 squared. Okay, and then if we wanted the standard deviation, let's see, what is this going to be? This is going to be 0.04 plus 0.16 plus 0.09. So 25, so isn't that, I think that's going to be 0.25 plus 4, 29. And so the standard deviation is going to be the square root of that, 0.29. And this is where I just got to check because something doesn't look right. So what's 0.29 squared? 0.538, so 0.54. Yeah, that's going to work. That's right. So 0.54. Okay, so what's left in the box is we expect to be at 12.3 ounces, but there's a lot of variability contributing to that number. Okay, so that's how you do these problems. It's quite a bit of stuff, but this is one of the better problems. If you can do this one, you're probably in good shape.